We shall solve example number 10. Check whether the polynomial fx is equal to 4x cube plus 4x square minus x minus 1 is a multiple of 2x plus 1. In this problem, this problem is related to checking whether the polynomial is a multiple of 2x plus 1. Expected to know what is the meaning of this is a multiple of. That is important. Now, just we shall take one numerical example. I will take fx as 6 and 2 and 3. So 2, 3 is 6. If you read like this is a factor of 2 is a factor of 6. 3 is a factor of 6. If you read like this, is a multiple. That means 6 is a multiple of 2. 6 is a multiple of 3. That means indirectly this problem is dealing with getting the remainder of 0. It is not given, but this signifies is a multiple of. So this 6 is nothing but, so your fx is a multiple of 2x plus 1. Fx is a multiple of 2x plus 1. Means 2, when you divide by 6, you will get the remainder as 0. 6, when you divide it by 2, 2, 3 is 6, 0. So remainder is 0. That means we have to prove the remainder is 0. Now let us take the polynomial. Let fx is equal to 4x cube plus 4x square minus x minus 1. Call it as result number 1 by remainder theorem. We have remainder is equal to f of minus 1 by 2, because 2x plus 1 is equal to 0, which implies x is equal to minus 1 by 2. Now we have to substitute the value of x is equal to minus 1 by 2 in that polynomial. That means we should get the remainder as 0. So to prove remainder is equal to 0. Now we shall prove remainder is equal to 0. So remainder is equal to 4 into minus 1 by 2 whole cube plus 4 into minus 1 by 2 whole square minus 1 by 2 minus 1. So this is equal to 4 into, you will get 1 by 8 with minus sign plus 4 into 1 by 4 plus 1 by 2 minus 1. So minus 1 by 2 plus 1 plus 1 by 2 minus 1. Plus 1 minus 1 cancels, minus 4 half. So 0. Therefore, so what we got? Remainder is equal to 0. Therefore, fx is a multiple of 2x plus 1. This ends the problem. So ultimately we will get the remainder is equal to 0. That is the main concept in this problem. Example 11. The polynomials ax cube plus 3x square minus 3 and 2x cube minus 5x plus a, when divided by x minus 4, leave the remainders r1 and r2. Here not given the actual remainders, r1 and r2 respectively. Find the value of a if 2r1 is equal to r2. When you analyze the problem, he has given two polynomials with only one unknown a. When divided by x minus 4, leaves the two remainders r1 and r2, and he has given the relation connecting r1 and r2 to find the value of a. This is the problem. Now we shall solve this problem. Let us take first polynomial as fx, ax cube plus 3x square minus 3. Result number 1. Here, let us take another polynomial. This polynomial. Let gx is equal to 2x cube minus 5x plus a. When both the polynomials are divided by x minus 4, that means we shall apply the remainder theorem. By remainder theorem, we get remainder is equal to f of 4, because x minus 4 is equal to 0 implies x is equal to 4. But the remainder is already given. This is the remainder r1. So r1 is equal to f of 4. So r1 is equal to, put x is equal to 4 in this polynomial. A into 4 cube plus 3 into 4 square minus 3. So a into 64 plus 3 into 16 minus 3. This is equal to 64a plus 48 minus 3. So 64a plus 45 is there. So this is your R1. This is result number 2. We shall take this as result number 3. By remainder theorem, we get remainder is equal to f of 4, because x minus 4 is equal to 0 implies x is equal to 4. But this remainder is given. It is R2. R2 is equal to f of 4. 2 into 4 cube minus 5 into 4 plus a. Into 4 plus a. This is equal to 128, 20 plus a. So 128 minus, so that is, you will get 108 plus a. This is your R2. So call it a result number 4. Now separately we got R1 and R2. But he has given to find the value of a if this condition is given. So now we shall take that given condition. 2R1 is equal to R2. 2 into R1 I already found out. 64A plus 45 is equal to R2. That is 108 plus A. So multiply by 2. 128A plus 90 is equal to 108 plus A. So 128A minus A is equal to 108 minus 90. 127A is equal to 18. So A is equal to 18 by 127. This is your required answer. So A value is 18 by 127. Just you have to use that condition. Apply the remainder theorems for both fx as well as gx and get the relation between R1 and R2 and use that condition and obtain the value of A. Here we got one linear equation. Solve. We will get the value of A. Now we shall solve an example from what number should be added to 2x cube minus 3x square minus 8x plus 2 so that the resulting polynomials leaves the remainder 10 when divided by 2x plus 1. That's all. He is asking what number should be added to that polynomial. Now we shall take the polynomial as fx. Let fx is equal to 2x cube minus 3x square minus 8x plus 2 is that number 1. Now we don't know what number should be added. Let k be added to fx. After adding, we get the resulting polynomial. Let us take that resulting polynomial as gx is equal to 2x cube minus 3x square minus 8x plus 2 plus k. Call it a result number 2. Before adding, I have taken it as fx. After adding k to the fx, we get one more polynomial, the resulting polynomial. We take it as gx. Gx is after adding. Now, after adding this, this will leave the remainder 10. It will leave the remainder 10 when divided by 2x plus 1. Now we shall apply remainder theorem. By remainder theorem, we get remainder is equal to f of minus 1 by 2 because 2x plus 1 implies x is equal to minus 1 by 2. So we should obtain the value of the polynomial at x is equal to minus 1 by 2. Now, but the remainder is given in the problem. Remainder is 10. So 10 is equal to f of minus 1 by 2. This implies, conversely, f of minus 1 by 2 is equal to 10. Now we shall substitute the value of x is equal to minus 1 by 2 in this gx. So not gx, not the this one. F, I should take it as g. Because We are dividing gx by 2x plus 1, not this. Because after adding, we will get one new resulting polynomial. So gx. Now we shall find, substitute the value of x is equal to minus 1 by 2. 2 into minus 1 by 2 whole cube minus 3 into minus 1 by 2 whole square minus 8 into minus 1 by 2 plus 2 plus k is equal to 10. So 2 into minus 1 by 8 minus 3 into 1 by 4 minus plus that minus plus. So 8 into half plus 2 plus k is equal to 10. Now, so we'll get minus 1 by 4 minus 3 by 4 plus 4 then 2 plus k is equal to 10. Now we shall simplify. Minus 1 by 4 minus 3 by 4 plus 6 by 1 plus k is equal to 10. We shall take LCM 4, that is minus 1 minus 3 24 plus 4k is equal to 10 by 1. So on cross multiplying, we will get minus 4 plus 20, that is 20 plus 4k is equal to 40. 4k is equal to 40 minus 20, that is 20. So k is equal to 20 by 4, which is equal to 5. Therefore, k is 5. Hence, 5 is to be added to fx to get gx. So this is our final answer. So what should be added? What number should be added? K is equal to 5 is to be added to fx, so that the resulting polynomial, that is gx, leaves the remainder 10 when divided by 2x plus 1. So the value is to be 5. That's it. Factor theorem. We have already studied earlier remainder theorem and its concepts, and we did the illustrative problems. Now we shall study factors of a polynomial. We have dealt with all the polynomials, many types of polynomials, and polynomial can be factorized. So we get the factors. Now we take a polynomial gx. E is called factor of the polynomial fx. If gx divides fx exactly, this is important, exactly or completely, that means nothing, no remainder will be left. If there is a remainder, it should be 0 1, giving 0 as the remainder. Now we shall take an example. So let fx is equal to 2x square plus 7x plus 6. Now we shall factorize this expression. 2 into 6. With 2 and 6, we can't get 7. We shall split this 6. 2 3 is 6. Now we can regroup this 2, 2, 4, 3. Now we got 4 and 3. So it is plus here. So both should be plus. Now come to the y model. So 2x square plus 4x plus 3x plus 6. We are splitting the middle term, that is 7x. This is equal to, take 2x as the common factor, x plus 2 plus 3 as the common factor, so you get x plus 2. Take x plus 2 as a common factor, then 2x plus 3 is there. So we got x plus 2 times 2x plus 3. So this is nothing but your fx, that is, this is your fx. Therefore, therefore 2x square plus 7x plus 6 is equal to x plus 2 into 2x plus 3. Now, see, this is fx and gx. This can be treated as 2x square plus 7x plus 6 x plus 2 into 2x plus 3. Now 2x square plus 7x plus 6, if you factorize, we will get x plus 2 times 2x plus 3. We can say x plus 2 is a factor of this fx and 2x plus 3 is a factor of fx. That means it will leave the remainder when you divide it by x plus 2, and when you divide by 2x plus 3 it will leave the remainder 0. So this is a typical example. So a polynomial gx is called factor of the polynomial fx if gx divides fx exactly. That means on dividing, so the remainder will be 0. Remainder will be 0, giving 0 as the remainder. Exactly the same way, when we divide 2x square plus 7x plus 6, a polynomial divided by x plus 2, the remainder is equal to f of minus 2. So you will get 0. Similarly, you will get the remainder is equal to f of minus 3 by 2. Here also the remainder will be 0. So this example illustrates the concept. A polynomial gx is called a factor of the polynomial fx if gx divides fx exactly or completely, giving 0 as the remainder. If we apply remainder theorem, we will get the remainder. So if we get 0, then we say gx is a factor of fx. After knowing the basics of concept of factor, just we have the previous example we have shown. Now we are going to prove the theorem, that is the factor theorem. So this is the statement of the factor theorem. Let fx be a given polynomial and alpha be a real number. So in the statement, what is given? A polynomial is given and a real number is given. Then we have to prove x minus alpha is a factor of fx if and only if f of alpha is equal to 0. Proof. Let us take let fx be a given polynomial and alpha be a real number. This is given data. So we know by remainder theorem. That means we already learned the remainder theorem. Now we are using remainder theorem to prove the factor theorem. So we know by remainder theorem that when a polynomial fx is divided by x minus alpha, one more polynomial, you can call it as gx. This is fx and this is gx. Then we get the remainder is equal to f of alpha. That is value of the polynomial x at x is equal to alpha. Now, x minus alpha is a factor of fx. Implies implied by, or if and only if. Remainder is equal to 0. If and only if f of alpha is equal to 0. Hence, the factor theorem. This proves the factor theorem. Very simple and very easy. Once when you know the remainder theorem, factor theorem is very, very easy. So, instead of we will get the remainder as 0. Then it is called as factor theorem. Now we have already proved the proof of factor theorem. There are 4 deductions. Deduction number 1. X plus alpha is a factor of fx if and only if f of minus alpha is equal to 0, because x plus alpha is equal to 0 implies x is equal to minus alpha. Now, deduction 2. Ax plus b is a factor of fx if and only if f of b by a is equal to 0, because ax minus b is equal to 0 implies x is equal to b by a. Deduction 3. Ax plus b is a factor of fx if and only if f of minus b by a is equal to 0. Because ax plus b is equal to 0 implies x is equal to minus b. And this should be not plus, this should be minus. So deduction 2 is ax minus b is a factor of fx if and only if f of b by a is equal to 0. Since ax minus b is equal to 0 implies x is equal to b by a. Now, deduction 4. X minus alpha times x minus beta is a factor of fx. This is both included. Is a factor of fx if and only if f of alpha is equal to 0 and f of beta is equal to 0. Please note that here we are using and because we are considering both. So f alpha is equal to 0 and f beta is equal to 0. These are the 4 important deductions related to factor theorem. We shall do illustration 1. Using factor theorem, show that x minus 3 is a factor of the polynomial x cube plus x square minus 17x plus 15. Now let us take the solution. Let fx be a polynomial x cube plus x square minus 17x plus 15 by remainder theorem on dividing fx by x minus 3. We have f of 3 is the remainder. We should prove it is 0 because x minus 3 is equal to 0 implies x is equal to 3. Actually f of 3 is the remainder, but we have to show that it is a factor, means we have to prove the remainder is 0. So now we shall calculate f of 3. F of 3 is equal to 3 cube plus 3 square minus 17 into 3 plus 15. 27 plus 9 minus 51 plus 15. So if you add all this, so you get 51 minus 51, this is 0. So therefore, we got the remainder as 0. Therefore, x minus 3 is a factor of fx. Illustration 2. Show that 2x plus 7 is a factor of 2x cube plus 5x square minus 11x minus 14. Hence, factorize the given expression completely using factor theorem. Now, we shall take the given polynomial as fx is equal to 2x cube plus 5x square minus 11x minus 14. By factor theorem, we have to prove f of minus 7 by 2 is equal to 0, because 2x plus 7 is equal to 0 implies x is equal to minus 7 by 2. Now we shall substitute in this polynomial 2 into minus 7 by 2 whole cube plus 5 into minus 7 by 2 whole square minus 11 into minus 7 by 2 minus 14. This is equal to 2 into minus 343 by 8 plus 5 into 49 by 4 plus 11 into 7 by 2 minus 40. So this you will get minus 343 by 4 plus 245 by 4 plus 77 by 2 minus 14 by 1. So take LCM. LCM is 4 minus 343 plus 245 plus 154 minus 56. So this will be equal to, after simplifying, we will get 399 minus 399. 399 minus 399 divided by 4. This is equal to 0 by 4. 0. Therefore, 2x plus 7 is a factor of fx. This is the first part of the problem. So we got the remainder as 0. Remainder f of, here you can, therefore f of minus 7 by 2 is equal to 0. So therefore 2x plus 7 is a factor of fx. First part is over. Now we have to factorize the given expression complete. This expression we should factorize. We shall go to margin 2x cube plus 5x square minus 11x minus 40. We shall factorize. Divided by 2x plus 7. So 2x square, x square. So 2x cube plus 7x square. Change the sign and add. So we get minus 2x square minus 11x minus 40. Right, minus x. That is minus 2x square minus 7x. Change the sign and add minus 4x minus 14 minus 2 14. Zero. On dividing fx by 2x plus 7, we get quotient is equal to x square minus x minus 2. Therefore, we can write fx is equal to 2x cube plus 5x square minus 11x minus 2. This is nothing but 2x plus 7 into x square minus x minus 2. So we got the two factors. We shall split this. So 2x plus 7 into x square, 2 1 ja, we can take it, minus 2. This is equal to 2x plus 7 into x minus 2 into x plus. This is your method.